600 meters. That was the predicted distance between two satellites above Siberia. Close? Yes. A collision? Well, no. At least, that was what the numbers suggested. One satellite was working normally. The other had been dead for years. Neither made an avoidance maneuver. Then, at about 1656 UTC, Iridium 33 stopped talking to Earth. Tracking radars checked the area. They did not find two satellites, they found two clouds spreading throughout orbit. The predicted miss had become a direct hit, and now there was a much bigger question. How can two tracked objects in a sky this large arrive at the same place at the same second? Iridium 33 was an American communication satellite. It was part of a network that carried satellite phone calls across oceans, deserts, and places far from normal mobile coverage. It had been in orbit since 1997, and on February 10, 2009, it was still working. The second spacecraft was Cosmos 2251. Russia launched it in 1993, but its mission ended years before the collision. No signal, no control, no way to move it. But in orbit, dead does not mean still. Cosmos 2251 kept circling Earth at several kilometers per second, a silent machine weighing almost a ton. Iridium could move, Cosmos could not. So, if their paths became dangerous, there was only one option: find the danger early and move Iridium. The satellites were about 790 kilometers above Earth. Their orbits crossed at a sharp angle, and together they were closing at around 11.6 kilometers per second. That is almost 42,000 kilometers per hour. At that speed, 10 kilometers disappear in less than 1 second. The final kilometer takes less than 1/10 of a second. And there is no last-second escape. No time to see the other satellite and turn away. By then, physics has already made the decision. The only protection is prediction. And that is where the story becomes uncomfortable. You know, satellites are tracked from the ground. Radar measurements are used to calculate where each object should be hours or days later. The result can look very precise. In this case, about 600 meters. But that number did not mean they will definitely miss by 600 meters. It was only the center of an estimate. A prediction is not one perfect dot. It is more like a small cloud of possible positions, a small error in location, a small error in speed, and enough time for those errors to grow. In 2009, the public tracking data available to commercial operators was not accurate enough for reliable collision avoidance. Routine screening also covered far fewer satellites than it does today. The close approach did not become an avoidance maneuver. The numbers said the satellites should pass each other. Reality took a different path. Above northern Siberia, the two satellites met. There was no sound, no fireball anyone could watch from the ground, just an impact lasting a fraction of a second. Iridium 33 weighed roughly 560 kilograms. Cosmos 2251 was closer to 900. At hypervelocity, metal does not crumble like it does in a car crash. It shatters. Satellite bodies, solar panels, antennas, batteries, and electronics broke apart almost instantly. Both spacecraft were destroyed, but losing two satellites was only the first result. The real damage was just beginning. Radar soon began cataloging the wreckage. About 2,300 fragments were large enough to track, and many smaller pieces were not. Every fragment left the impact with a slightly different speed and direction, so the wreckage spread into new paths around Earth. It was no longer one collision point, it was a moving field of hazards. Some fragments slowly lost altitude and burned up, others remained in orbit, crossing the paths of working spacecraft. In 2011, the International Space Station changed its orbit to avoid a fragment from this collision. The impact was over in an instant. Managing its consequences was not. Iridium recovered quickly. An in-orbit spare replaced the lost satellite only weeks later. The phone network returned to its full configuration, but orbit could not be repaired in the same way. There was no switch to turn off the debris, no crew that could collect thousands of fast-moving fragments. The only practical defense was to keep tracking them and move other spacecraft when necessary. The communication system recovered. The environment around Earth did not. The collision changed how seriously close approaches were treated. Before the accident, the US Joint Space Operations Center routinely screened about 120 maneuverable satellites. Within months, that number had grown to more than 800. Before 2009, some operators still trusted an idea known as the Big Sky Theory. Space is enormous. A collision may be possible, but it is so unlikely that it can almost be ignored. Iridium-33 and Cosmos 2251 ended that argument. Earth orbit was no longer just empty space, it was shared infrastructure. And shared infrastructure needed traffic management. The collision also revealed a deeper problem. One impact creates debris. That debris raises the chance of another impact. And the next collision creates even more debris. This is the basic idea behind the Kessler syndrome. It does not mean that every satellite suddenly crashes at once. It is slower than that. One accident makes the next one slightly more likely, then the next and the next. NASA models had already suggested that collisions between objects currently in orbit could make the debris population continue growing, even if no new satellites were launched. Iridium-33 and Cosmos 2251 did not begin that process, but they prove that a major accidental collision was no longer just a theory. Some disasters leave a crater. This one did not leave any place you could visit. Its evidence kept moving, round and round the planet. That is why this collision belongs to the Atlas. It turned something that looked almost impossible into a danger every satellite operator now has to plan for. And somewhere above us, thousands of silent objects are still crossing paths every day. Most of them will miss. But as Iridium-33 discovered, a predicted miss is not a promise. And honestly, if stories like this make you want to look a little deeper, stick around. There are plenty more failures hiding behind things that look completely safe. Subscribe to Failure Atlas, and if there is a story you think belongs on this channel, tell me about it below. Maybe we will investigate that one next. See you in the next story.